So this is an organic chemistry assignment. This assignment is related to both alkanes and alkenes. And in organic chemistry, questions usually like drawing the structures, that is also a common type of question, and the reaction mechanisms as well. So first 28 questions I have solved. So I will start with first 29 are done. So I will start with 30. This include both MCQs and the structure questions. As in exam as well, you will have both or structure and the structure questions as well as the MCQs in the same paper. So in question 30, this question is about the chemistry of alkenes, which are unsaturated. State what is meant by unsaturated as applies to what is the meaning of unsaturated. The term unsaturated means they contain carbon-carbon double bond in the structure. So if there's a carbon double bond is there within the structure, we call them as unsaturated. If it is single bond, then we call them as saturated. Organic compound X is unsaturated hydrocarbon with a molecular formula of C4H8. Draw a displaced formula and give the two branch molecule with a E and Z. E and Z are geometrical isomers. What will happen like if we want to draw E means like they're attached when the molecules are there, we have to draw E and Z. Like it depends on which side we have heavy groups are there. If heavy groups are attached on the same side, we call that as a cis or Z. And if it is attached on the opposite side, we call that as a trans. Like example, first for these type of structures, whenever you want to draw the geometrical isomer, draw this structure first thing. Then we have 4 carbon atoms. So one carbon we attach here. So that will be CH3. Hydrogen will be here. One carbon we attach here and hydrogen will be here. This will become, when you count, it will become C4 and H8. When we check the heavy groups, as you can see here, hydrogen and methyl, so which is heavy? CH3 is heavy. When we check hydrogen and methyl, which is heavy? CH3 is heavy. So when the heavy groups are attached on the same side, so what we call that as a Z. And because it is 1, 2, 3, 4 carbon, so it is bute because of 4 carbon. And the second and the third carbon have a double bond, so it is 2-ene. So this is Z butene. But if we want to draw another one, like if we draw CH3 here and H, now if I draw CH3 and H on opposite side, so when we check the heavy groups here, CH3 and H, so CH3 is heavy. H and CH3, CH3 is heavy. Here the heavy groups are on the opposite side, so we call them as E. And what is the name of the compound? 1, 2, 3, 4 carbon atoms, so it is bute. Second position, they have 2 and ene. So this is E-butene. So one is E-butene, another one is Z-butene. Even Z-butene, I can draw other way around. Like if I draw hydrogen at the top and I draw CH3 at the bottom. Like if hydrogen is at the top and then the CH3 are there at the bottom, that is also Z-butene. It does not make difference, but the idea is that when we compare the heavy groups, like these two are heavy, when we compare these two are heavy, so heavy groups are on the same side, then it will be Z. If heavy groups are on the opposite side, it will be trans or E. But why I did not draw like this, like why did not bute one in? So if I draw like two hydrogens, One hydrogen here, then CH2 and CH3. Or I can also draw in this manner, like this might be CH3 and this might be CH3. Now, this is actually not an optical isomer. It cannot be E or Z. Why it cannot be E or Z? Because this is H and this is also H. Identical groups are there, so we cannot compare. Here also, this is CH3, this is CH3, so we cannot compare. So it cannot have a geometrical isomer. Same way, if I draw the structure, if this is having like I put H here, I put H here, then I put H and then CH2, CH3. Here, when I compare the heavy group, this is heavy group. But again, the same problem, we cannot compare these two. No one is heavy, like both of them are same. So there is no heavy group. So this cannot have a geometrical isomer. So to be a geometrical isomer, we check the two carbon atoms which are having a double bond and they must have a different molecules attached to them or atoms attached to them. So we can identify which one is heavy and which is lighter. If heavy groups are attached on the same side, we call that as a cis or Z. If the heavy groups are attached on the opposite side, so we call that as a trans or E. This in detail I have explained in the last week. The chemical properties, no, the chemical properties for isomers, the chemical properties does not change. If it is a functional group isomer, yes, it will change, but not in this case. Only the physical properties changes. Both isomers react with the solution of acidified potassium manganate. So acidified potassium manganate, what is the color change? The color changes from purple to colorless. Draw the structure of a product of either. So whenever acidified potassium manganate is used, it is reacting with alkene. Remember one thing, whenever there is an alkene and we have acidified potassium manganate, KMnO4 is there, it will become diol. Diol means like the carbon-carbon double bond will break. How you know the color change? It's already there. I have shared with you. You have to learn the color change for acidified potassium manganate. It's from purple to colorless. I have shared already this. So it will become a diol. How you draw the structure of a diol? Diol means like the two carbon atoms, like the carbon-carbon double bond. Like any one of the structure, like this was our. If I take this was the structure. First structure was this. When I draw Z E, so what will happen? The carbon-carbon double bond will break. Like this carbon-carbon double bond will turn into a single bond. And both sides, the OH group will attach. This will have OH. This will also have OH. So whenever acidified potassium manganate is used, it will convert alkene into diol. The term diol means like two alcohol groups will be attached. That's called diol. Compounds such as C4H8 are formed when fractions of a crude oil are cracked. State what is meant by the term cracking when applied to a process of fractions obtained from a crude oil. So what is the definition of a cracking? Cracking is actually breaking down of a large molecule into a smaller hydrocarbons. Like breaking breaking a carbon-carbon single bond or breaking down the molecule or a large hydrocarbon into a small hydrocarbon, that is called cracking. Write the equation to show the cracking of a hydrocarbon C into C4H8 and a saturated hydrocarbon has only one product. So we want one of the product For this case, many possibilities are there. Like example, write an equation to show cracking of a hydrocarbon octane. So oct means C8, and to be an alkane, what is the journal formula of alkane? Cn H2n plus 2. Number of hydrogen will be twice plus 2. So 16 plus 2 makes 18. So this will be C8 and H18. When we crack, as a result, one of the product is C4H8. So what will be the other product? The other product will be, because 8, so there will be 4 as well. And out of 18, we use 8. So how many? 10 will be there. So C4 and H10. Because the octane, which is C8 and H18, when we crack, it will become C4H8, that is given already. So what is the second product? The remaining 4 carbon and 10 hydrogen. So it will be C4H10. Then another alkene, which is a propene, describe the mechanism that, as you remember, we did today. Mechanism of this addition reaction of a propene with bromine to form C3H6Br. In your answer, you should include the name for the type of addition which occur, the name of the product, and the mechanism using a curly arrows to show the movement of electron pair. So what kind of addition reaction is this? So alkenes undergo electrophilic. So there will be electrophilic addition reaction. Name of the product. What is the name of this product? So like the two bromines that will be attached to the carbon atoms, first and the second. So it will be 1, 2. First and second position, there will be 2 bromines, so dibromo. And because there will be carbon-carbon single bond and 3 carbon atoms are there, so it will be prop and single bond in. That will be the name of the product. So 1 and 2 position, there will be bromine attached, 1, 2 dibromopropane. Now mechanism means like how this reaction proceed. So how this reaction occur, that is the mechanism. So if we draw, like first we draw propene. Better when you're showing the mechanism, show all the bonds. It will be much more easy to represent when you're writing or showing all the bonds. Like this is propene. So we have a bromine in there. So which bromine will get a partial positive? This will get a partial positive. This will get partial negative. Drawing the arrows is 1 mark, like in this case. So from a double bond, you will show arrow towards the partial positive, and this will take their electron back. So what will be the, like this is the first thing what happened, then this will be H, H. Now we have to write a mechanism for like a bromine. In this case, any one of them will have a like, what might happen if a bromine is attached to this carbon? If a bromine is attached to this carbon, this will be partial positive. And if a bromine is attached to this carbon, this will be partial positive. But which is more likely to happen? If a bromine is attached to the second carbon, this will have only 1 carbon chain. But if a bromine is attached to a first carbon, if a bromine is attached to a first carbon, this will be carbon cation. This carbon cation will be more stable. Why it will be more stable? Because it is surrounded by more alkyl groups, and alkyl groups are electron releasing groups. So they reduce the positive charge on the carbon cation, which will make it more stable. And then the second bromine, which is having a negative charge, the second bromine, which is having a negative charge, is attracted towards the carbon cation. So as a result, this will be the product. So which carbon cation will form? Don't always check the one which is surrounded by more alkyl groups, that is more stable. So this will form 1,2-dibromopropane. Is it clear? The mechanism of electrophilic addition reaction. In this example, propane with bromine. Any doubt or a question in this? Okay. Then propene can be polymerized to form polypropene. State the reason. The atom economy of this, state with a reason. Look, what is the atom economy? Atom economy is basically the mass of a desired product divided by the total mass of the reactant or the product into 100. So in addition reactions, always the mass of a desired product is always same as the mass of reactant, because the desired product is the only product. So when we work out the percentage atom economy, these two will be same, so they cancel out each other. So whenever addition reaction is there, what is the atom economy? The atom economy is always 100%. Why it is 100%? Because the only product which is formed is a desired product. That's why. Then draw a section of this polymer. So propene can be polymerized. We want to draw a polymer. So this is a propene. So this is a propene. We want to draw polymer. We just have to draw the section. So this is one. This is another. And we link them together by a single bond, because the double bond will break and it will turn into a single bond. So this is a section of the polymer, the part of a polymer which is having a. But don't put a bracket and N. Why? Because they did not ask draw the polymer. They asked just a section of the polymer, the part of a polymer. What happened in a polymerization? The small unsaturated hydrocarbon, they break the bond and turn into a carbon single bond, and they form a long chain compound. This is you did in IGCSE chemistry as well, the organic chemistry, drawing the different polymers, addition polymer. Polypropene is used to make synthetic fiber, which is extremely light and it is good insulator, act as a good insulator. Comment on the sustainability of this use of a polypropene, like whether this use is sustainable, because like from where we get, what is the source of a propene? First, we have a crude oil. From the crude oil, we do a fraction distillation, and from fraction distillation, we get alkane. Then from alkane, we do a cracking and we get alkene. And for alkene, then we polymerize to get polyalkane, like polymer. But the problem here is this sustainable way of uh, the sustainability of this use? It is not. Why? Because crude oil is not renewable. Like the supply of a crude oil or the sources of the crude oil are limited. So crude oil, like it is not so sustainable. Why it is not sustainable? Like we cannot do this for a very long time. Why it cannot be done for a very long time? Because the propene is actually from the crude oil, and the crude oil, the amount of a crude oil or the supply of a crude oil is limited. So it is not sustainable. Like it cannot last for a very long time, as a crude oil is not renewable. Like the rate at which the crude oil is forming is very slow as compared to rate with which we consume. So it is not sustainable, like it cannot last for a very long time. And what is the reason for that? Because the source of propane or propene is a crude oil, which is not renewable. And when we say it's not renewable, like it's the rate at which it is forming is much slower as compared to rate of the consumption. So we will run out of the crude oil. So this was question 13 from organic chemistry. So unit 4 is done. So now what we'll do, every session we'll just take certain topic and we'll do a question from these classified papers. Any question or doubt related to the session today? So unit 1 is done and next week we'll start unit 2.